So, pirate stuff, yar. I'm here to talk about pillage ops. One of my friends suggested that I'm here to pillage all of your stack traces, and I agree with that. So, I wrote a pirate app. Yes, a pirate app. I needed something vaguely pirate-related to talk to you today, so I wrote an app called Battleship. Who here has played Battleship? Apparently it's also called Sink the Ships in some places. Yeah, it's that thing where you have ships and you try to guess where the other person's fleet is. Pirate-related, vaguely pirate-related. Parrot's looking at me funny. So, details, it's Ruby, it's Sinatra, Postgres is the backend, I'm running it on App Engine Flex. And I wrote this a couple weeks ago. I've done a whole series of blog posts about how I designed the API and how I deployed it and stuff. There's one coming out tomorrow, maybe Thursday, about lessons learned doing this project. But it turns out it wasn't particularly fast, because I wrote the bare minimum code I needed to actually do the thing. So I'm going to talk to you about figuring out where performance bottlenecks are and the tools that Google has available for that. And that tool is Stackdriver. That is the only pirate joke I'll be making after this, up to this point. So, Stackdriver, what is it? Who here has tried it before or used it or has any idea what I'm talking about? Yay, that is the correct number of hands, which is basically none. I get to teach you something. So, Stackdriver is Google's suite of performance, logging, and diagnostics and monitoring tools. We've got logging aggregation, we've got monitoring both at the application level and at the server level, and other network devices, load balancers, and cool stuff like that. Diagnostics includes Trace, which is APM, error reporting, and a really, really cool live debugger that you can run in production. Not that anyone here has ever debugged a site in production. Certainly I haven't, never. And the cool thing about it is that it runs everywhere. One of the reasons I really like talking about this product, and I work with the team pretty closely, is I can run it on GCP, I can run it on AWS, and if you are fortunate enough to be willing to run your diagnostics and logging suite as beta software, don't recommend it, but you can run it on-prem if you're using Ruby, C#, or Node.js. More languages coming soon, watch this space. So we're going to start talking about Trace, because that's the thing that says application performance monitoring in the title. And this is perf like a pirate, so perf, yes. So application performance monitoring, what? Application performance management, APM, or application performance monitoring is this name that somehow a bunch of tools that we've probably all at least squinted at over the past 5 years got. I don't know why. It helps you see how your application is performing. The name doesn't actually help. So this includes things like showing how your request time is distributed. Like, are you spending most of your time in the database? Are you spending most of your time rendering? Are you spending most of your time making remote calls to other people's services because other people's services are slow? Maybe you should cache that sales tax data. You can also aggregate trace data from multiple requests, or you can aggregate data across microservices architecture. One of the super cool things about Stackdriver Trace is that distributed tracing is built in from the start. Let me just double check. Yes. And also, you can aggregate trace data across multiple requests. You can see the performance of your system more holistically. I don't know about you, but I have been tasked in the past, before I worked at Google, with this one request for this super important customer is really slow. The service is just falling over. Everything's on fire. You got to fix it. And I'm like, yes, that one request was very slow. And that is a sad thing. But 99% of the other requests were not slow. So do you really want me to spend the next 4 days trying to figure out why this person's internet connection is broken? Or can I go on to the stuff that we were actually going to work on? So that being able to see stuff in aggregate versus looking at individual requests is really good for making those decisions. So I'm going to show you some of the cool features that Trace has. So this is the Trace overview. Axes aren't labeled because the screen cap I took didn't catch them. Time of day is on the x-axis. Request length is on the right axis. And sadly, my little Battleship server didn't get a ton of traffic because my friends didn't want to play with it very long. So this is a screen cap from an app with much more use. This is the app my team uses to track our whereabouts and our activities and all of the other stuff we do. And if you see that the usage curve is pretty normal. Most of the requests are in the bottom section right there. I like this view because you can really clearly see if there's outliers, like that one. That one's an outlier. But you can also see, perhaps, if your app has a time of day usage curve. One of the places I worked before Google was at an educational software company, and so all of our use happened between 8 a.m. Eastern and 4 p.m. Pacific during the week. Never on snow days, never on holidays, and basically nothing during the summer, and basically nothing on weekends. So we had a really specific usage curve, and it would have been really easy to see this there. We could also see that earlier requests in the day, as individual districts' internal caches warmed up, tended to take longer than other requests later in the day. So I can click on that little dot right there in the interface, and it'll give me something that looks like this. So you can see that there's the time at the top is the entire request, and you can see each of the little pieces underneath is some time it took to something that request did. Turns out that this part, this request makes like 300 calls to the Google Calendar API. I only showed the first 7 there, but it scrolled for like 8 more pages before it gave up. But that's why this one took forever. Maybe we shouldn't be making all of those requests to the Google Calendar API in a single request. Maybe we should cache that, or run it on a cron, or something else, so that we don't have a request that takes, what, over 200,000 milliseconds? That's too many. Here's another request, and this one is more interesting. This is an App Engine app, and you can see that it's showing the total request time. Sometime it used to call the Google's metadata server on the instance to get keys or service accounts or whatever it needed, potentially environment variables. If you haven't played with the metadata server yet, I have a video on it. It's super cool. It's a great way to update information on your services without having to like re-provision them. I've spent way too much time watching provisioning scripts set up new machines for me. Much prefer this. But you can also see that most of the time for this particular app was spent in data store. And there's a button. I can look at the logs for this request. If I'm like, this makes no sense, I would like to see my logs. So that cannot be my timing. Anyways, so if what you see makes no sense, you can look at the logs. Trace detects also detects certain types of problems. It can detect missing database indexes. It can detect mixed configuration of resources like your memcache server. It can also detect other common mistakes, especially if you're running on App Engine or using one of the languages that Google supports on App Engine standard. And then there'll be, if it finds one of those in your request, there'll be an insights pane at the bottom and says, hey, you're missing an index. And if you're using Cloud SQL, it might even have a button that says, would you like to add that? We can add that for you. But it's not like Clippy. You can ignore it if you want to. It's just, I don't know about you. I've always worked on relatively small teams that were pretty poorly provisioned. And so when I could actually have someone, tell me what I was doing wrong, it saved me a bunch of time reading Stack Overflow and trying things that didn't work. And honestly, at the end of the day, we want your app to run fast because we want your customers to be happy, because if your customers are happy, you're happy. So we're going to give you as many tips as we can, and we're constantly adding to the list of insights that we can detect for various apps, various languages, and things like that. So there's more. So traces are kind of boring, honestly, like individual traces picking things out. What I'm more interested in is looking at specific classes of things, or looking at all the traces for a particular URL. So you can search. You can look under a particular HTTP method. When I first tried my Battleship game with a group, we did a code retreat style thing where everyone tried to write a Battleship client, and it just randomly started dropping posts. And so I'm like, well, okay, let's look at trace and see what it says for all the posts. And it turned out that a bunch of my posts were timing out. And so Rails was killing them, and so they weren't getting back to Nginx, and so nothing was coming to the client. And I wouldn't have been able to see that as easily if I hadn't been able to filter by the HTTP method. Also, some of us, like me, may perhaps work in a language where method dispatch is one of the most expensive things that you do and can hurt your performance the most. And it's even double if you're going through multiple layers of exception catching. There are other languages other than Ruby where exception catching is slow. And so being able to look at statuses like 500 or anything in the 500 family can help you find those really quickly and see if that's affecting your performance. But most people don't actually care about stuff on an individual request level. Honestly, at the end of the day, everyone wants to know is, did my app get slower? This is my favorite feature of trace, because the number of times that I've had an argument with someone when I was carrying my pager and wearing my ops hat, which is not fundamentally different than my pirate hat, they're like, it got slower. No, it didn't. It got slower. No, it didn't. It got slower. No, it didn't. If I could show them a graph like this, where it's week over week, this is what it was the week before we did the release, here's what it was the week after we did the release. Look at the request frequency. It's a histogram. It's a curved histogram. It's a histogram. Yeah, it looks like it wasn't actually too bad. And just in case, you can also look at it as a chart, where you can look at the percentiles. So you can see that this is the same data as before, but you can see that the 25th percentile got 30% slower. It's still 13 milliseconds, so don't care. The 50th percentile request actually got slightly faster, which is cool. But all of the ones above that got slower as well. So there might be something to it got slower. However, if you can detect on average let's say 10% or even 5% slower app when we're measuring things in milliseconds, I am impressed. So this is really, really handy when you're trying to answer those questions and figure out what happened. We actually have used this on some of our internal apps within my team a fair amount. We're like, everyone's saying it's slower and awful and everything's dying. We're like, it's not. We just have a lot of people using it today, and we have a limited number of database connections, so it's not actually slower. You're just doing really, really hard queries, go away. So the other thing Trace does is if it will detect bottlenecks in your app, it will appear and let you know where your app is slowing down. So this particular one is saying that we're spending a lot of time in data store running queries. Maybe there's a way to optimize that. Maybe you should lay out your data slightly differently so that the queries run faster. Also, I got to use the really cool 16-bit bottle graphic on this one. I'm super excited. So honestly, if I was looking at performance issues in a web app, Trace is the primary tool I would use. There's a lot of other tools that are out there, but I really like this one, and I like that you can use it with everything. And if you're using one of Google's products, especially if you're using App Engine, it comes for free with App Engine. So if you're running on App Engine Standard, you already have it. You may not have ever looked at it, but it's there for you. But there's other tools in the Stackdriver suite that can help you out. So monitoring. Monitoring lets you set up dashboards and alerts. It's a monitoring application. This is not surprising. So some of the things that I would use to look for performance bottlenecks using monitoring is I would be looking at request latencies. You can set up alerts on the 5th percentile, 25th percentile, 50th percentile, 95th percentile, and 99th percentile. And you can decide where it makes sense to have your latency alerts. Honestly, I have never cared about that last 1%. I've never had an app where that actually mattered. Now, I don't work on apps that keep planes in the sky or keep people alive. If you do, maybe you care. I would hope you do. So you get to figure out what makes sense for you. You can also look at things like response codes and see if there's trends in response codes. You can set thresholds. You can also set rates of change. If your latency is going up significantly over a period of a couple hours, that's a hint that something's not okay, and that perhaps you should look at it more closely. And the monitoring and alerting system, you can have dashboards, but you can also get alerts. And you can get alerts via most likely your favorite tool, PagerDuty, Campfire. I think Campfire's in there. Slack, HipChat, email, SMS. There's a lot of stuff that's integrated. And you can just get alerts in the way that makes sense for your team. Also, custom metrics. I think everyone who's spent much time in industry, especially working on crazy, crazy ideas from startups, has had some idea that their metrics are special. Sometimes they're right, sometimes they're not. But if you have a special metric, you can instrument certain parts of your app and send custom metrics up to Stackdriver and then see dashboards and get alerts on those. Not relevant to performance, but one of my favorite custom metrics was, we just made a sale, which we had an alert on that then played a cha-ching sound in the office. And when we had a chargeback, it played the cha-ching backwards. Because, you know, we were a brand new startup. We had just started selling stuff. It was super exciting when people actually like, we want to give you money. And we're like, that is awesome. Do more of that. Other tools that you have available. Oh, I skipped a slide. There we go. Error reporting. So Google, if you have logging, you get error reporting. You can also set up error reporting independently. Again, libraries available for language of your choice. Ruby is beta-ish. It will be beta shortly. I don't feel bad saying that because I'm working on making that happen real soon now. JavaScript, Node.js is beta. I believe that for some forms of .NET, there is a beta or GA version of this. And basically all this does is it looks at your app. And depending on the language, it might set up a top-level exception catcher. It might hook into the existing framework that detects errors and then renders the 500. It does the right thing for the language. One of the reasons that we haven't just shoved libraries out the door is that we're trying to make sure that it integrates with the tools that you already use. I am lazy. I am a Rails dev. These two things sometimes go together. I want to be able to say, gem install this thing and have it work. And I wouldn't sign off on it until we got there, and that works now, and I'm very happy about that. For Node, it's slightly more complicated because that's just how the Node ecosystem works. For C#, it's different, but not more complicated within the context of the tool set. There's IDE integrations where it makes sense, and all the cool stuff that you would expect if you are a .NET developer. Sorry, it's .NET, it's not C#, it's .NET, because it integrates with all the languages. But what this does is it catches stuff, it groups errors in logical ways, it tells you, hey, you got an error. And this is actually from a Node app that I broke by doing really, really dumb things. And it counts the number of times it happens, it alerts you when you have an error. Who here has gotten alert spam and wanted to just throw the pager across the room? Okay, at least one other person has had that bad day. I've had that bad day. It was not good. It has logical back-off. It won't alert you more than a certain number of times an hour because it figures you either don't care or you're already on it and you haven't gotten to fix it yet, so telling you loudly will not help. I like that feature. It makes me happy. And then it also shows you things like, what was the first version this showed up in? Has it showed up in the most recent version? It links to a stack trace. It'll give you links to the stack trace. From the stack trace, you can get to the logs. You can also link it to your bug tracker. I'm on it. And all these things may or may not help with perf, but again, if you're coming back to one of those languages where throwing an exception, rendering a 500, having a mistake is really expensive performance-wise, especially if you're in a language that's single-threaded, like my friend Ruby, where you can't handle another request until you resolve this 500, this is a great way to look and see if something unrelated to the other request could be causing request latency. One of my favorite days was the day we had a bunch of stuff backing up at the Nginx layer because we didn't have enough Ruby workers to pick it up, and the ones we had processing long requests. So it wasn't that the requests that seemed slow were slow in Ruby, which is the part we could see. It was that everything before it was slow and was slowing those down. And if we had just had a tool like this to look at the errors, we could have put things together much more easily. Anyways, errors are generally not good. I know that almost every app has a normal amount of error noise, but using a tool like this, you can get a much better high-level picture. So, logging in BigQuery. I'm going to never, ever, ever recommend that logging is the first place anyone goes to address performance issues. Logs are noisy, logs are ginormous. I don't find logs particularly helpful. That said, I have an entire folder on my hard drive of tools to analyze Rails logs and tools to analyze Node.js logs. So maybe I'm saying do as I say, not as I do. But I'm not you. So maybe you have very good reasons to go to your logs first. Maybe you don't trust anything but the raw logs. Awesome. You do you. Stackdriver logging is the log aggregator. There are tons of log aggregators out there. Ours is super nice because we give you 50 gigabytes a month for free. After that, we give you some additional if you have Stackdriver Premium per monitored resource, load balancer, server. 50 gigabytes doesn't sound like a ton, but it's actually plenty for most people most of the time. And even better, we let you actively exclude stuff that you don't want to have cataloged. So like, I don't actually monitor any, I don't save my logs from my health checks. I don't care. They're loud, they're noisy, they don't help. So I just have those go away. And I don't import them into the logging engine. But if for some reason I need them, I can hit the export button and get the file from Google Cloud Storage. It's still there. It's still saved. I just don't want it to be imported so I can search it, because I don't care about my health checks. So nice things about logging, lots of cool filtering features. I actually just did a blog post and a video about this. If you want to know more about filtering, you can come find me, or you can go find my blog, or find me on Twitter and harass me there. Lots of cool stuff here. Advanced filters. The other cool thing is you don't like our interface. Awesome. You're allowed not to like our interface. You can export to cloud storage. You can export to a web hook. So you can I would like you to feed all of my logs to this other log aggregator. That's sad, but OK, you get to do that. Or you can export to BigQuery. And I like BigQuery, and it's amazing. And it was kind of designed with searching and understanding logs in mind. And I get to use SQL, and I like SQL. SQL's my friend from a very, very long time ago. And BigQuery's great at dealing with massive amounts of data. Terabytes are not an issue for it. So I hope I don't ever have to deal with terabytes of logs to try to find a problem. I hope I can narrow it down before I get there. But, everyone gets to have a couple bad days on the internet. So, yar. So, I don't have a lot else to say about Stackdriver. I don't have a lot else to say about performance, but I want you to know that there are tools out there, and the biggest thing is that if you use a tool like Stackdriver, everything's integrated. My primary message on Stackdriver, it's all in the box. I've watched so many presentations at meetups from folks who are like, I want to tell you about our stack. And I'm like, that's awesome. Tell me about your stack. And then they get to the slide where, like, there's the first slide, which is the one I had, language, framework, database, hosting environment, awesome. But then there's the next slide where it's, here are all the monitoring tools we have. And it's like 2 columns, and it lists like a dozen products. And I'm like, how do you keep all that straight? Also, isn't that expensive? And I've been there. I've had, the log monitoring tool. I've had the uptime monitoring tool. I've had the server monitoring tool. I've had the tool that monitors the application. I've had application performance monitoring. I've had log aggregation. And I didn't have a live debugger. And I think that catches all of them. And I was at a consultancy the last time I had to deal with this. And so whenever anyone rotated onto our project or off of our project, we had to go to all of those sites, take their access away, or we had to share accounts. And as Jen just taught us earlier today, sharing accounts is bad. We should not share accounts. And it was just a huge pain. And so Stackdriver's got some rough edges. There are some things I really wish it would do that it doesn't do quite yet. We're working on it. But if it hits the 80-20 rule and it's all in one place and it's $8 a month per monitored resource, I can't actually complain that much. For medium-sized companies, it's got a lot to offer. And we've got a lot of large companies using it. And they give us feedback all the time, and we listen to their feedback and try to integrate it better. So I encourage you to just give it a shot, try it out, see if it helps you. If you find stuff that's super cool, let me know. If you find stuff that's super broken, also let me know, and I will pass that on to the team. And especially if it's for Ruby or Node, because those 2 libraries, I have the line into those teams. So I just want to say thank you. I am _Thagamizer on Twitter. I like tweets a lot. You should tweet at me. Tell me pirate jokes. That'd be fantastic. I mentioned my blog post on Stackdriver filtering, and my blog post on my Battleship thing. My domain is www.thagamizer.com. And because everyone always asks me this, and I have a couple extra minutes, a Thagamizer is the spiky part at the end of a Stegosaurus. And I very much like dinosaurs, hence my dinosaur t-shirt. And it was named by Gary Larson in the Farside comic, and as scientists do, they're like, that didn't have a name. That's a great name. We should totally use that one. So just giving you a little background on why it's that. It's perfectly phonetic. And again, I'm Aja Hammerly. Thank you very much.